just a yes or no?
Yeah.
Yes.
Okay, use the right triangle trigonometry.
Yeah.
And I think if you take a peek at, actually, I don't know, how about the ratio of the vertical red leg to the diagonal length in black, which is r? If I
To
look
do cosine,
Theta
right?
goes to 0.
Cosine of theta.
H goes to 1.
So I agree with that. Oh, let's go that far. I think the ratio of red to black is nothing more than the ratio of the adjacent sides of the purple angle to the hypotenuse, but that's going to define nothing more than the cosine
Cosine of r minus h over r. Or
Oh,
theta.
true, you're right. I just meant the cosine of what angle?
Yeah, it's cosine of theta.
Cosine of,
Theta over 2.
thank you.
Yeah.
Cosine of theta over 2. And so that's the relationship. Again, keep in mind that r is a constant. Don't let that bother you. It's just a number. That being the case, I think we can find a relationship between these two pieces. Actually, I don't know, can you replace the cosine of theta with something easily? I asked, can you replace the cosine of theta halves with something easily?
Oh, maybe some half angle rules or something?
Yeah, the half angle identity says the cosine of theta halves is nothing more than, I'm hyperventilating. Guys, cosine of theta halves?
1
Root plus or minus.
root 1
No, oh, it's not plus or minus root.
Cosine?
1
Plus
plus or
plus
cosine?
cosine of
2
No, cosine.
Theta.
theta
Over
over 2 is equal to this fraction.
But doesn't the half angle have to be plus or minus?
Yeah, you're right, but jeepers, look at my picture. Isn't the cosine of theta halves going to be a positive quantity?
Yeah.
I mean, theta has a acute angle. So I first suppress the plus minus components. I want a yes or no answer. Can I replace this cosine of theta with an expression involving r's? I misspoke. Involving h's.
Do you have to solve? No, not
But answer my question. Can I replace the cosine of theta with an expression involving h's?
No.
Well, I mean,
Yeah. Just multiply by r and then subtract the other r.
Too much work. No, just square both sides. And then
multiply
both sides by 2. And then
negative 1.
subtract 1 from both sides, and I think I get 3 over 5 times the quantity 1 minus squiggly line, which we just recited off, is equal to d theta dt. Ah, shoot, you guys, it didn't work. I'm supposed to find dh dt, and I got a d theta dt. How do I fix that?
You're going to have to differentiate
I'm
with
going to have to
h in there.
differentiate.
Yeah.
And I think of differentiating this piece right here. Right here. What are you guys looking at?
But that's not right.
What do you mean?
This is like saying something really weird about the half angle.
That's
Is that right?
cosine squared theta.
Okay, well, wait. Hold it. No. You guys, she's looking at the book. She's saying that. She's saying, help me with this.
This
Cosine.
is half angle formulas, that's what threw me off.
She's-
It says cosine squared theta equals 1 plus cosine 2 theta over 2.
And they're calling that
All
what?
over 2. What?
They're calling it what?
Half
They're
angle
calling it
formula.
half angle.
If you take the square
You
root
know,
of both sides.
technically speaking, that's really not the half angle identity. It's kind of a version of it, but you watch me. Just relax and let me play with this for a minute. If I came in and tried to solve, oh, you guys, I don't know. How about the further cosine of theta? Can I get this? And if you allow me to make a substitution, every time you see a theta, let it be represented as y over 2. Then doesn't it become the cosine of actually theta is now y over 2? Being equal to plus or minus the square root of 1 plus the cosine of 2 theta, which is nothing more than y, all over 2. Isn't that exactly what I have? Okay, so I changed the name of the variable again. I went back to theta. I think it says the same thing.
Okay.
It's just when the author wrote that, there are times so often in mathematics, particularly math 31, for which this version of the half angle identity is really interesting to have because when we undo the differentiation process, this thing pops up from time to time.
Trigonometric
And
stuff.
And yeah, exactly. And so replacing with this sometimes is so nifty. So the author called that as half angle identity. I think he meant that's a result of the half angle identity.
Okay.
But do you at least agree with me as opposed to what I have?
Yes.
And in my application, I suppress this garbage. because I knew my angle was acute. As long as you believe me. And everybody, that means I gotta replace d theta dt with an expression involving dh dt. How the heck am I gonna do that?
Plug in
Plug in what?
stuff. What was the question?
The question is this, I have not answered the question. Because I'm trying to find out how dh dt is changing. So I'm in trouble. I got d theta dt and I'm not happy. I need to somehow replace this with an expression called dh dt. How the heck am I going to do it?
As d theta dt goes to 0, dh dt, or
Doesn't see right? I think you're thinking. And you're saying, well, yes, these go to 0. I want to not think. I want to be really lazy.
Wait, can't you just plug in what we found to be cosine of theta, solve, and then you're gonna have h in terms of d theta dt?
That's fine. I agree. Or you could have done this. You could have just said, well, take this relationship to differentiate both sides with respect to t. And you can equate d theta dt to dh dt. You can do that. Sorry. I saw the clock.
Don't worry about it.
I'm worried. I worry a lot. Do you guys see that?
Yes.
Okay. As long as you see it, I'm happy.
so what was the answer?
I didn't answer it. Actually, I'm not going to answer it. It's just so much arithmetic or algebra. I would have to take the time and replace this squiggly line with, actually, I don't know what I was replacing it with. I never wrote it.
Yeah.
Did you solve for cosine?
I never did. So let's solve for it. Multiply both sides by 2.
-1.
And thank you. And now subtracting 1 from both sides. Doesn't that tell me another name for the cosine theta is 2 r, excuse me, I can't read that. I said 2 r minus h squared
Over r squared minus 1.
over r squared minus 1. Does that look too complicated?
Yes.
No. Piece of cake. Is equal to d theta dt. D theta, I said dt. And so I think d theta dt is nothing more than, yikes, I can't read that. Is that a negative 3/10 r minus h squared with an r squared upstairs? I'm just trying to simplify. Don't take this the wrong way. R is just a constant. It's not a variable.
Isn't that negative distributed over, because you're substituting that whole value in for cosine theta, so I don't think you'd have a cancellation there, because that negative times that -1 would be a +1, so you have 2. You see what I mean?
I see completely what you mean. He's saying I made an algebraic blunder. You know, technically speaking, another name for the cosine of theta is 2r minus h squared over r squared minus 1. And if I were to subtract that from the 1, technically speaking, I have made an algebraic blunder. Because I think the negative sign on the outside changes the sign of both these terms. Technically speaking, he's right. I really have, I don't know what I have. Is that a 3 over 5 times? Is that a 2 minus 2r minus h squared over r squared? Thank you very much. I didn't even see that. I completely missed it. Oh shoot, we're not done. Now we've got to replace d theta dt with, now we've got to replace d theta dt with an expression involving dh dt, or dh dt. And so I have to go back to this relationship. Ah, piece of cake. Now you differentiate both sides with respect to t and make a replacement. It's just a bit of algebra. Do you guys mind if I don't finish that? Because now I got to differentiate both sides with respect to t and make a substitution. And it'll work.
Oh, that's a lot of work.
Yeah, I think it was a lot of work. I think that wasn't quite involved. Oh, you got